Hello everyone, my name is Parasani Bharat from ITA section. Today I am going to discuss about membrane filtration technology. Membrane filtration technology is a pressure-driven separation process widely used in water purification, water wastage treatment, food processing, pharmaceutical and chemical industries. It works by using semi-permeable membrane that allows certain components, usually water or s- smaller molecules, to pass through while rejecting larger particles, microorganisms, and dissolved contamination. Membrane filtration technology is a separation process that uses a semi-permeable membrane to separately allow certain molecules or particles to pass through while retaining large particles, microorganisms, or dissolved contaminated driven by the pressure difference between membrane. Principles. Principle of membrane filtration is based on selective permeation, where a pressure difference forces a fluid through a semi-permeable membrane that allows smaller molecules to pass through while blocking larger particles, microorganisms, or solvents. Size execution. Large particles larger than the membrane pores are retained while smaller ones passes through. Charge-based separation. In some membranes, electrostatic interaction helps repel and attract charged particles, impacting separation efficiency. Pressure gradient has driven force. Applied pressure pushes the feed solution towards the membrane, causing clean water to remain two feed side types. Membrane filtration processes are mainly classified based on porous size, operation pressure, operating pressure, and separation capability. The four major types are microfiltration, ultrafiltration, nanofiltration, reverse osmosis, forward osmosis, reverse osmosis, forward osmosis, membrane bioreactors, electrodialysis, gas separation membranes used to separate gases like oxygen, nitrogen, and carbon dioxide. Application of membrane filtration technology in the water and wastewater treatment, the purification of drinking water, the removal of bacteria, viruses, and turbidity, MF/UF, desa- desalination of seawater, treatment and recycling of industrial wastewater, removal of heavy molecules and toxic chemicals, NF/RF, food and beverage industry, milk protein concentration and lactose removal, UF, juice clarification and stabilization, beer and wine filtration, concentration of food flavors and extracts, pharmaceutical and biotechnology sector, sterilization of solutions, MF, solution and purification of proteins, enzymes, and antibodies, dialysis members applications, preparation of injectable water, chemical and petrochemical industries, separation of solvents and chemical mixtures, recovery of valuable products, treatment of cooling and processed water, medical applications, hemodialysis, blood purification, sterile fil- filtration for injectable drugs, membrane oximeter in critical care. Environmental protection, removal of microplastics, treatment of landfill leachates, recovery and reuse of industrial resources such as water and chemicals. Industrial manufacturing, boiler feed water purification, electronics and semiconductor grade water production, oil water separation, properties of membrane, selective permeability. Membranes allow specific molecules to pass while retain large particles, microorganisms and solvents. Porous size dependent separation. Filtration efficiencies depend by membrane pore size. Pressure driven process. Separation relies on pressure gradient across the membrane for fuel flow, fluid flow. Physical and chemical stability. Membranes must resist pressure, temperature, pH changes, and chemical cleaning agents. High surface area. Membrane molecules offer large surface area for filtration in compact systems. Hydrophilic and hydrophobic nature affects flowing behavior of stability for different fit solutions. Selection rejection characteristics can block particles on based on size, charge, molecular weight, chemical affinity, reusability, and cleanability. Many molecules support backwasting, chemical cleaning, or physical cleaning. Low energy requirement. MF and UF requires low moderate pressure, making them energy efficient. Molecules and scalable designs. Examples: Mo- microfiltration. Examples are removal of bacteria from drinking water, clarification of free juice, etc. Filtration. Examples: concentration of milk proteins in dry industries, removal of viruses and colloids from water, etc. Nanofiltration. Examples: soft soft softening of hard water by removing calcium and magnesium ions, removal of dyes from textile wastewaters, etc. Reverse osmosis. Example: seawater desalination plants, domestic RO water purification, etc. Another life examples are oil water separation in industry, membrane based gas separation. Advantages: high separation efficiency, no chemical additive required, production of high quality water, low energy consumption, compact and moderate design, operates at ambient temperature, selective separation, easy automation and control, high recovery and reuse potential, consistent product quality, environmentally friendly. And finally, conclusion. Membrane filtration technology is highly efficient and versatile separation method widely used across water treatment, processing, pharmaceutical, biotechnology, and chemical industries. But by utilizing semi-permeable membrane and pressure-driven mechanisms, it enables selective removal of particles, microorganisms, and dissolved contaminants with high precision and minimal chemical usage. Its modular design, ability to produce high quantity output, and environmentally friendly operations makes it as efficient modern alternative and controlled filtration methods. These are the references of our program. Thank you.